Okay, welcome to Mr. Wilczewski's stoichiometry lessons. This is section 4, mole-to-mole problems. In A, we'll do a demo practice quiz and then homework, and then in 4B, we'll do an opener. Okay. Here's an example problem. For the reaction represented by this equation, how many moles of nitrogen are required to produce 40 moles of ammonia? So, look at the problem, see what you're trying to find. You're trying to find moles. How do you know? Because it says how many moles of nitrogen are required to produce 40 moles of ammonia. Now, you're making ammonia, but you already know the amount of ammonia. So you're not trying to figure out how much ammonia. You're trying to figure out how much nitrogen you need to make the 40 moles of ammonia. So, if you're trying to find moles of nitrogen, and the data that they're giving you is 40 moles of ammonia. So it's a mole-to-mole problem. So look at the Flintstone, look at your stoichiometric Flintstone equations. You're starting out with moles, so you don't have to worry about those first sets of equations. And you're going to multiply by the molar ratio here. And that'll give you the moles that you want to find. So this is the simplest problem you could work with. So for a plan, you're trying to find the moles. You're starting with the moles of the unknown, and you're going to build your mole ratio so that you have the moles of the find, the coefficient, in front of the moles that you want to find, the coefficient coming from the balanced equation. That's the numerator. The denominator is the coefficient in front of the known chemical in the balanced equation. That represents the number of moles of the known chemical, and that goes in the denominator. So let's actually do the problem. You have moles of nitrogen, starting with 40 moles of ammonia. So you want to get the moles of ammonia to cancel, so they go in the denominator. And the moles of nitrogen to appear, they go in the numerator. So look at the balanced chemical equation. In front of nitrogen here, there's nothing. Well, the equation is balanced, so that's understood to be 1. You should just always do a quick check to see if the equation is balanced. And then in front of the ammonia, there's a 2. So your mole ratio is 1 mole of nitrogen over 2 moles of ammonia. Before you begin your math, always check your units. So your moles of ammonia cancel here and here. Now you can do the math. This one you could probably do in your head. So on a good day, I can. 40 times 1/2 is 20 moles of nitrogen. All right. Here's a practice problem. I want you to tackle this problem and see what you can do. For the reaction represented by this equation, how many moles of nitrogen are required to produce 9 moles of ammonia? All right, so pause the tape, give it a go, come back when you're ready. Okay, so first, what type of problem this is. They're giving you moles of nitrogen, and you're asked to find moles of ammonia. So it's a mole problem, which means you're interested in just the middle part of your stoichiometric equations. And your plan to find those moles that you're looking for, you're going to take the known moles and multiply by the molar ratio with the coefficient of the moles that you want to find in the numerator and the coefficient of the known moles in the denominator. All right, so let's actually do it. We're looking for moles of nitrogen, given 9 moles of ammonia. Your molar ratio will have moles of ammonia in the bottom, so it cancels. Moles of nitrogen up top. Look at the balanced chemical equation here. In front of the nitrogen, there's a 1 that's understood. In front of the ammonia, there's a 2. Okay, so your mole ratio is 1 to 2. Make sure those units cancel. Then do the math. 9 times 1/2, 4.5. Okay, so here's a quiz question. Why is it not showing up as a quiz question? Bear with me a second. Okay. There we go. All right. So the process for producing ammonia commercially is represented by this equation. To completely convert 67.0 moles of hydrogen gas to ammonia gas, how many moles of nitrogen are required? Okay, pause the tape. Give it a shot, see what you come up with. All right? Okay, so let's take a look at this. It's the same problem. I just made it a little smaller. So there's room. So this is another mole-to-mole problem. So you're interested in the core part of the stoichiometric equations. In order to find those moles you're looking for, you take the moles of the known and multiply times the mole ratio. You're looking for moles of nitrogen from 67.0 moles of hydrogen. So your mole ratio will have moles of hydrogen in the denominator and moles of nitrogen up top. Now look at the balanced chemical equation. In front of hydrogen there's a 3. That's 3 moles of hydrogen. And in front of nitrogen there's understood to be a 1. So your mole ratio is 1 over 3. Alright, so make sure those units cancel. Do the math. Pause the tape for a second. Do the math. Come back when you've got an answer. Let's see if it's the same. Alright, 22.3 moles of nitrogen. Okay. Alright, so let's do another practice problem. Here you have oxygen and hydrogen making water. And the question is, to completely convert 67.0 moles of hydrogen gas to water, how many moles of oxygen are required? Okay, so they're giving you moles, and they're asking for moles, so that's a mole problem. So we're just interested in the core of the equations. So to find the moles you're looking for, you take the moles of the known and multiply by the mole ratio. So let's do this. The moles of oxygen that you would need to react with 67.0 moles of hydrogen, or build your conversion factor. Hydrogen moles down the bottom, moles of oxygen up top. Look at the balanced chemical equation. In front of oxygen there's an understood 1. In front of hydrogen there's a 2. So your mole ratio is 1 to 2. Make sure those units cancel. Then do the math. 67 divided by 2 is 33.5. All right. So now we have a homework problem. All right. So having a little trouble with the PowerPoint. Okay, so here's a homework problem. For the reaction represented by this equation, how many moles of nitrogen are required to produce 32 moles of ammonia? Okay, so PowerPoint. Okay, I just need to clear off this blue so we can actually do it. Sorry, I'm having trouble with the PowerPoint again. Okay, so we'll do this in class. You have a mole-to-mole problem again. And in order to convert the moles of the known to what your moles you're looking for, you build your mole ratio with the coefficient in front of the moles that you want to find over the ones that are known. So to find the moles of nitrogen from the 32 moles of ammonia, your mole ratio has nitrogen in the numerator and ammonia in the denominator. So look again at your balanced chemical equation. You have 1 in front of the nitrogen and 2 in front of the ammonia. So your mole ratio is 1/2. So make sure those units cancel. And so 32 divided by 2 is 16. Okay, so now, if we were in a real class, an in-person class, this is a real class too. If we were in an in-person class, I would then have you do those homework problems at home, and then when you came into class on the board, there would be an opener quiz. So you'd have to do this first thing as soon as you got there. All right, so since you're watching this online, you got the benefit of, well, we just went over the homework problem, so you've seen that. And now let's do the opener quiz. Click through this. All right, so here's the quiz. With the reaction represented by this equation, how many moles of nitrogen are required to produce 137 moles of ammonia? Okay. This PowerPoint is giving me a lot of trouble today. When I see them, sorry about this. May have to actually. Okay, so there we go. All right, so how many moles of nitrogen are required to produce 137 moles of ammonia? Apologize for that. Technology is acting funky today. All right, so it's a mole-to-mole problem. You're trying to find so many moles from the moles of the known. You multiply by your mole ratio. So 137 moles of ammonia. Use that to calculate your moles of nitrogen. You got your moles of ammonia in the bottom, your moles of nitrogen up top. So your mole ratio is 1/2. Make sure those units cancel. Answer is 8.5 moles of nitrogen. Okay. Here's another quiz. We have nitrogen and hydrogen making ammonia. This time, we're asking you how many moles of hydrogen are required to produce 152 moles of ammonia. All right, so it's a mole-to-mole problem. To calculate the moles that you're looking for, you start with the moles that are known, multiply times the mole ratio. So your mole ratio, if you're trying to convert from moles of ammonia to moles of hydrogen, would have moles of ammonia in the bottom and moles of hydrogen up top. Look again at your balanced chemical equation. In front of the hydrogen, there is a 3. In front of the ammonia, there's a 2. So your mole ratio is 3 to 2. So make sure those units cancel. Do the math, pause the tape, come back when you're done. The answer is 228 moles of hydrogen. Okay, that concludes our lecture on 4 mole-to-mole problems.